SwayamPrabha. Digital India. Educated India.
Welcome to lecture 22 of the course on multivariate data mining methods and applications. The title of this lecture is Rosenblatt's single layer perceptron. Rosenblatt's single layer perceptron provides a fundamental milestone for the development of artificial neural network. It was developed by Frank Rosenblatt in late 1950s. This is consists of an input layer and an output layer. We combined the inputs using weights. Remember that in threshold logic unit also we combine the inputs, but we do not use any weights for combining the inputs and then to get the output. And we do not even use any activation function, whereas in Rosenblatt's single layer perceptron we use weights for combining the inputs, and then we also use the activation function, though in between we do not have any hidden layer. So, in this lecture we are going to discuss the Rosenblatt's single layer perceptron, its architecture, its learning mechanism, etc. So, we consider feed forward single layer network. In feed forward single layer network, the graph is a set of vertices or nodes, and these nodes represent the basic computing elements. Then it also has a set of edges, and these edges represent the connections between different nodes. Then directed graph or digraph. In digraph, edges are assigned an orientation. We assign an orientation to the edges, so that numerical information flows along each edge in a particular direction, in the direction of the orientation actually. In feed forward networks, the information flows in one direction, that is from input nodes to the output nodes. So, we get the input data from input nodes, and then the information flows in one direction towards the output nodes. Acyclic graph. The acyclic graph has no looks or feedback. Now, suppose you have R input nodes or R input variables, which are x1, x2, xr, and then you have S output nodes or S sync nodes or neurons or S output units or S output variables, and these output variables or output nodes are y1, y2, ys. These are S output variables. So, we have R input variables x1, x2, xr, and then we have S output variables y1, y2, ys. And these nodes can be real valued or binary, that is discrete values. Now, we consider single layer network. In single layer network, the output involves computation. Input nodes, which is also called the 0th layer, involves no computation, except sometimes you may require some scaling of input variables, etc. And this input node is not a layer of learnable nodes. Then connection from x j to y l carries connection weight, say beta j l. So, x j is the jth input variable, y l is the lth output variable, and x j is connected with y l through a connection weight, say beta j l. Actually, this beta j l, which is just like the regression coefficient in the context of multiple linear regression model, gives you the strength of the connection, between x j and y l. Now, we consider Rosenblatt's single layer perceptron. Now, this is an artificial neural network with a single layer of computational units, that is neurons, and these computational units are arranged in a linear manner. So, you have input variables, and then we combine the input variables in a linear manner, and then it also has only a single layer of computational units. This is actually a generalization of McLaughlin-Pitts neuron, but now these inputs xi's come with connection weights. Remember that in McLaughlin-Pitts neuron, we combine the inputs without using any weights, whereas in Rosenblatt single layer perceptron, we use connection weights also. We combine the inputs using the connection weights. Then Rosenblatt single layer perceptron is capable of learning linearly separable patterns. So, if the patterns are linearly separable, then you can use it, and it is primarily used for binary classification tasks. So, if you want to classify the observations into one of the two classes, then you can use it. Now, x 1, x 2, x r are the input variables, and these input variables can be binary or real valued. Then beta 1, beta 2, so on beta r, these are the connection weights, and the magnitude of beta I shows the strength of the ith connection. Then we define u equal to summation j equal to 1 to r beta j x j. So, u is actually the weighted sum of input variables. The weights are these beta j's. Then suppose y takes value 1 if u is greater than or equal to theta, theta is some threshold value, and y takes value 0 otherwise. Then you can write y as the indicator function I u minus theta greater than or equal to 0. So, obviously, this indicator function takes value 1 if u minus theta is greater than or equal to 0, or u is greater than or equal to theta, and it takes value 0 otherwise. And then you can get an alternative formulation if you write beta naught equal to minus theta and x naught equal to 1. and then you write u equal to summation j equal to 0 to r beta j x j. So, in this case y is equal to 1 if u is greater than or equal to 0 and 0 otherwise. Notice that here u is equal to summation j equal to 1 to r beta j x j. Here you have modified u as summation j equal to 1 to r beta j x j minus theta, say, or you can write minus theta here. So, minus theta plus summation j equal to 1 to r beta j x j, and then you are writing minus theta equal to beta naught. So, this is equal to beta naught and x naught is equal to 1. So, beta naught x naught plus summation j equal to 1 to r beta j x j. So, you can write it as summation j equal to 0 to r beta j x j. Now, these are the two equivalent representations of Rosenblatt's single layer perceptron with r inputs and connection weights beta j's, and then you have a binary output y. So, if we are using the threshold theta, then the perceptron with threshold theta is this. You have input variables x 1, x 2, x r, then you have connection weights beta 1, beta 2, so on beta r. You take summation beta j x j, which gives you u, and then you are using this threshold value theta, and ultimately you get y. Here we are using this bias element beta naught, which is equal to minus theta, and then you are taking x naught equal to 1. So, corresponding to x naught equal to 1, the weight is beta naught, and then corresponding to x 1 it is beta 1, and so on corresponding to x r it is beta r. Then you are taking summation beta j x j, j running from 0 to r. So, you get u, and ultimately you get the output y, which is a binary variable. Now, this function y, which takes value either 0 or 1, is said to be perceptron computable if for given theta there exists a hyperplane that divides input space into two half spaces, say r 1 and r 0, where r 1 corresponds to y equal to 1 and r 0 corresponds to y equal to 0. And then if r 1 can be separated without error from r 0 by a hyperplane, then we say that the two sets of points are linearly separable. And what is your hyperplane? Your hyperplane is summation beta j x j equal to theta j equal to 1 to r. This is the hyperplane which divides the input space into two half spaces, say r 1 and r 0, where r 1 is corresponding to y equal to 1 and r 0 is corresponding to y equal to 0. Now, this is your single layer network. In the earlier case, actually we have considered binary output variable. Here the output variables are y 1, y 2, y s. So, s output variables. You have inputs x 1, x 2, x r. Then we combine these inputs using connection weights, and then we get y 1, y 2, y s as the output. Now, suppose a particular weight is positive. Positive means what? Say, suppose this connection weight, which is the weight corresponding to the connection between x1 and y1 is positive, then this implies an excitatory signal, means as x1 increases, y1 increases, or increasing the value of x1 excites the value of y1. If weight is negative, then we say that the signal is inhibitory. If the connection weight between x1 and y1 is negative, then obviously increasing the value of x1 decreases the value of y1. Or you can say that if say x1 and y1, these are binary variables, then as x1 moves towards 1, if x1 is equal to 1, the chances that y1 takes value 0 increase. Weight 0 means it denotes a connection that do not exist in network. So, suppose this weight is 0, then it means that there is no connection between x1 and y1. So, it is just like the regression coefficient between y and x. If the regression coefficient between y and x is 0, then there is no relation between y and x. Now, we define activation function. So, again we have r dimensional inputs. Say x is equal to x1, x2, xr transpose. Then for given x, output node computes an activation value using linear combination of inputs plus a constant. So, corresponding to the lth output node, say lth linear activation function is u l equal to beta naught l plus summation j equal to 1 to r beta j l x j. So, beta naught l is the bias term, and then you have combined the input variables using the connection weights beta j l. Or in terms of vector notations, you can write it equal to beta naught l plus x transpose beta l, where beta l is the column vector with elements beta 1 l, beta 2 l, so on beta r l. For the Rosenblatt's single layer perceptron, you have this input layer. We combine these inputs with these connection weights, we get u, and then we also use some activation function. Notice that in the previous case, we have used this linear activation function. Now, suppose you are using some activation function f, then we take a function of u, say f u, and ultimately we get this output y. Or if you are using this kind of formulation, perceptron with a single computing unit divided into two functional parts, say additive function and activation function f applied to result u. That is, we are combining these inputs, and then we are taking the function f summation beta j x j, and then ultimately you get y. So, there is just a slight difference between these two representations. Means here first you are doing this computation, you are doing computation summation beta j x j, and so you get u equal to summation beta j x j, and then you apply the activation function f u, and ultimately you get the output y. Here, instead of doing these two computations separately, you are directly applying this activation function to summation beta j x j, and then you ultimately get the output y. Now, in this representation of the relationship between u's and input variables x's, beta naught L is the bias, then beta L is the vector of connection weights for all L equal to 1 to S. So, beta L is actually the vector beta 1 L, beta 2 L, so on beta R L transpose. Further, in matrix notations, we can write u equal to beta naught plus b x, where u is equal to u 1 u 2 u s transpose. So, this is S cross 1 vector. Beta naught is also S cross 1 vector of bias coefficients, that is beta naught equal to beta naught 1, beta naught 2, so on beta naught S transpose. This B is S cross R matrix with the different columns as beta 1, beta 2, so on beta S, and then we take transpose of this. So, actually beta 1, beta 2, beta S, these are different columns of B transpose. Then the threshold activation function for the Lth output node is say f u L. So, we are using this activation function f, and then f u is equal to f beta naught plus b x, which is equal to f u 1, f u 2, so on f u s transpose. Now, some of the activation functions which one can use are say identity or linear activation function, where f u is equal to u, and the range of f is the entire real line R. Then hard limiter activation function, which is the signature of u, that is takes two values -1 and +1. Heavy side or step threshold, this is the indicator function I u greater than or equal to 0. So, obviously, it takes values 0 and 1. So, its range is 0 1. Gaussian radial basic function. So, Gaussian radial basic function is actually the density function of standard normal distribution, and obviously, its range is R. Cumulative Gaussian. So, we integrate the PDF of standard normal distribution from -infinity to u. So, actually this gives you the cumulative distribution function of standard normal distribution, say we may denote it by capital phi u, and its range is the interval 0 1. Then logistic or sigmoid activation function is defined as say f u is equal to 1 plus e to the power minus u whole inverse. So, this is simply logistic function, and its range is the interval 0 1. Hyperbolic tangent. Hyperbolic tangent or sigmoid activation function is defined in this form: e to the power u minus e to the power minus u upon e to the power u plus e to the power minus u, and its range is from -1 to +1. Then Rosenblatt single unit perceptron. Single unit perceptron is a single layer feed forward network with a single output node. Then it computes the linear combination of input variables beta naught plus x transpose beta, and then it delivers the sign of beta naught plus x transpose beta, that is plus or minus as output. So, in this case we are using the activation function hard limiter, and then the output node is known as the linear threshold unit. Then a general version of single unit perceptron, instead of using hard limiter activation function, now we are using the activation function f. You can take this activation function as sigmoid or any other activation function. Generally we take it as sigmoid. Then we compute beta naught plus x transpose beta, and then we obtain f beta naught plus x transpose beta. Now we consider perceptron learning rule. So, suppose we write beta in place of beta naught beta. So, beta naught is the bias element, and then you have the weights beta. Now we are replacing it by say beta. Similarly, x, actually you have 1 x. This 1 is corresponding to the bias element, and then you have input variables in x. So, we replace it by x just to simplify the notations. So, that beta naught plus x transpose beta is replaced by x transpose beta, just to simplify the notations. Then suppose y equal to plus minus 1, depending upon whether the neuron fires. If the neuron fires, then it takes value plus 1, or it does not fire. Does not fire means it takes value minus 1. Then we divide the input space into, say, pi 1 is the set of values of x such that x transpose beta is greater than or equal to 0, and pi 2 is the set of values of x such that x transpose beta is less than 0. So, basically what you have done, you have divided the input space into two parts, say pi 1 and pi 2, where pi 1 is the set of values of x such that x transpose beta is greater than or equal to 0, and pi 2 is the set of values of x such that x transpose beta is less than 0. Then y takes value 1 if x belongs to pi 1, and y takes value minus 1 if x belongs to pi 2. So, the input values of x which belong to pi 1 are corresponding to y equal to 1, or you can say that whenever x belongs to pi 1, y takes value 1. Similarly, whenever x belongs to pi 2, y takes value minus 1. And basically you have to train your model. Training your model means you have to obtain the value of beta. So, suppose x1, x2, so on xn, these are independent copies of x's drawn from classes pi 1 and pi 2. So, you have taken independent copies of x's or independent samples, you can say, on the input variables, and these input variables come from pi 1 and pi 2. Then suppose the assumption that the observations are linearly separable. This assumption is satisfied. We say that observations are linearly separable if there exists a beta star such that pi 1 falls on one side of the hyperplane x transpose beta star equal to 0 and pi 2 falls on the other side of the hyperplane x transpose beta star equal to 0. Notice that pi 1 is the set of values of x such that x transpose beta is greater than or equal to 0 and pi 2 is the set of values of x such that x transpose beta is less than 0. Now, which hyperplane is separating these two sets pi 1 and pi 2? X transpose beta equal to 0. So, this is the hyperplane which is separating pi 1 and pi 2. So, if there exists a value of beta, say beta star, such that pi 1 falls on one side of the hyperplane x transpose beta star equal to 0 and pi 2 falls on the other side of the hyperplane x transpose beta star equal to 0, then we say that these observations are linearly separable. So, basically you have to obtain such a beta or beta star. Now, the algorithm for implementing Rosenblatt single layer perceptron or perceptron learning rule is defined here. This algorithm actually uses gradient descent algorithm and operates sequentially on input vector. Say we provide the inputs one by one and then using the gradient descent algorithm it trains the model. Say hth iteration deals with x h equal to 1 to n. So, initially we provide the observation x 1 and then we provide the observation x 2 and so on. We go up to x n and sequentially we train the model using the gradient descent algorithm. Now, suppose we set x naught equal to 0 and beta naught equal to 0, or you may set beta naught as very small value of beta. Then at the hth iteration, if x h transpose beta h is greater than or equal to 0 and x h belongs to pi 1 or x h transpose beta h is less than 0 and x h belongs to pi 2, then we set beta h plus 1 is equal to beta h. Remember that while training the model, you are providing the input variables and you also know whether the input variable belongs to pi 1 or pi 2. So, suppose x h belongs to pi 1 and x h transpose beta h is greater than or equal to 0. Greater than or equal to 0 means you are going to classify x h in pi 1. So, your classification is correct, or x h belongs to pi 2 and x h transpose beta h is less than 0 means you are classifying x h in pi 2. Again your classification is correct because x h comes from pi 2. So, in both of these cases or in the case of correct classification at the hth stage, we set x beta h plus 1 equal to beta h. If x h transpose beta h is greater than or equal to 0, but x h belongs to pi 2, means the classification is not correct. Then we set beta h plus 1 equal to beta h minus say eta times x h, or if x h transpose beta h is less than 0 and x h belongs to pi 1, then we set beta h plus 1 equal to beta h plus eta times x h. Here eta, which is greater than 0, is the learning rate parameter. So, this is how we implement this algorithm to train the model or to find the value of beta h. We can once we train the model, we can use it for the prediction purpose also. So, suppose we have a new input vector x, and basically your objective is to classify this input vector into either pi 1 or pi 2. Then we compute net input to each output neuron. Say you compute u l equal to beta naught L plus x transpose beta L. So, once you have trained the model, you know the values of beta naught L and beta L. So, you can compute u L for a new input variable x, and then we apply the activation function to compute the output of each neuron. So, we compute y hat L equal to f u L. Then we predict the class based on the neuron with the highest output. So, ultimate output is the predicted class based on the neuron with highest output. So, this is how you can get the predicted class corresponding to x. Perceptron convergence theorem. For a binary classification problem with a linearly separable classes, if a solution vector beta star exists, the algorithm will find that solution in a finite number of iterations. So, to prove this result, we just set eta equal to 1. Ultimately, if eta is not equal to 1, you can always scale the inputs and the weights so that eta becomes 1. So, the value of eta does not matter. Ultimately, you can scale the problem or the input variables and the weights to make the learning rate equal to 1. Then in that case, beta h plus 1 is equal to beta h plus x h, and then this is equal to beta h minus 1 plus x h plus x h minus 1. Say you replace this beta h by, just take beta h plus 1 in place of beta h plus 1, you take beta h. So, you get beta h minus 1 plus x h minus 1 here, and then you proceed further, and ultimately you get summation j equal to 1 to h x j. Remember that we have taken beta naught equal to 0. So, initially we have started with the weights vector equal to 0. Now, since the problem is linearly separable, there exists a solution vector beta star. Now, suppose capital A is the minimum of x I belongs to pi 1 x I transpose beta star, and B is equal to maximum of x I belonging to pi 1 norm of x I square. Then beta h plus 1 transpose beta star, we substitute the value of beta h plus 1, which is equal to summation j equal to 1 to h x j. So, we get summation j equal to 1 to h x j transpose beta star, and this is greater than or equal to h times a, because what is a? A is the minimum of x I belonging to pi 1 x I transpose beta star. So, we replace this by minimum of x I belonging to pi 1 x I transpose beta star, that is A, and then we get this inequality. Then using Cauchy-Schwarz inequality, beta h plus 1 transpose beta star whole square is less than or equal to norm beta h plus 1 transpose whole square norm of beta star whole square. So, we get this result using the Cauchy-Schwarz inequality. Now, we combine 1 and 2, and combining 1 and 2, we get this quantity greater than or equal to h square a square, or norm beta transpose h plus 1 whole square is greater than or equal to h square a square divided by norm beta star square. So, the square norm of the weight vector beta dash h plus 1 grows quadratically with number of iterations h, because it involves h square. So, as the number of iterations increases, this also increases quadratically in h. For x k belonging to pi 1, k equal to 1 to h. Now, we consider the update rule at the kth iteration, say beta k plus 1 equal to beta k plus x k. Then the norm beta k plus 1 square is equal to norm of beta k square plus norm of x k square plus twice x k transpose beta k. And since x k is incorrectly classified and x k transpose beta k is less than 0, we have norm of beta k plus 1 square is less than or equal to norm of beta k square plus norm of x k square, or norm of beta k plus 1 square minus norm of beta k square. You take norm of beta k square towards the left hand side is less than or equal to norm of x k square. Now, we take summation of this equation over k equal to 1 to h. So, finally, what you get? Norm of beta h plus 1 square less than or equal to summation k equal to 1 to h norm of beta k square, and then this quantity is less than or equal to h times b. Remember that if we take summation over k, then say for k equal to 2, what you get? Beta norm of beta 3 square minus norm of beta 2 square. For k equal to 1, what you get? Norm of beta 2 square minus norm of beta 1 square. So, beta 2 norm of beta 2 square will cancel out. So, this is how we can simplify this expression, and then ultimately you get this equation. Now, equation 7 shows that norm of beta h plus 1 square grows at most linearly with h. Now, for large h, inequalities 3 and 7 contradict each other. Just consider these two inequalities 3 and 7. Thus, h cannot grow without bound. We need to find, say, an h maximum such that both 3 and 7 satisfy. That is, h maximum square a square upon norm of beta star square is equal to h maximum b, or h maximum is equal to b norm of beta star square upon a square. So, h cannot grow without bound. So, in a finite number of steps you get the solution. Hence, the result follows. Now, we again consider this example which we have discussed in the last lecture. The loan officer is asked to put an applicant of a loan on the basis of 5-point scale, answer to a set of 10 questions, and the decision on the loan could be predicted based upon whether the applicant's total score surpassed the threshold or not. Now, different questions may be assigned different weights. Remember that in threshold logic unit we assign same weights to different questions, but different questions may be assigned different weights. Further, the approach which we have used here, this approach ignores possible non-linearities in the decision making process. So, if there is a non-linearity in the decision making process, then we cannot use the Rosenblatt's single layer perceptron. Say scoring high on a few specific questions ignores the response to all other questions in making a positive decision. Say suppose in a few specific questions the scores are very high, then the response to other questions does not matter. If a particular question scores very low, this may be sufficient cause for the application unsuccessful. Even if in other questions the customer has scored very high, but if he scores very low in a particular question, it may be sufficient to reject his application. Now, these are the limitations of perceptron. A perceptron can learn to distinguish two classes only if the classes are linearly separable. If the input space is not linearly separable, then it is not perceptron computable. So, in this lecture we have discussed Rosenblatt single layer perceptron. Although the single layer perceptron has the limitation that it can not be used when the boundaries are non-linear, but still it can be used as a foundation for more complex model like artificial neural network or multi-layer perceptron. In the next lecture we will discuss the multi-layer perceptron. So, I am going to stop here. Thank you.
Hello, I am A.K. Sharma and I teach sociology in IIT Kanpur. You may ask, how do sociologists view religion? Religion is becoming an important issue for our society. Now, sociologists, this is true that sociologists explain one thing in terms of other things of society. So, religion, if you ask sociologists to explain religion, they will explain religion in terms of other things of society like education, economic development. In sociology of religion, there are two major traditions actually. In one tradition, to use language of methodology, in one tradition religion is a dependent variable, in another tradition religion is an independent variable. What I mean is that in the view of Karl Marx, who said that religion is the opium of the working class, religion is closely associated with contradictions or relations of class in society. Marx believed that as time passes, societies evolve, and this evolution of society is dialectical, like from a classless society to a class society, class formation, and eventually again a classless society will emerge. Karl Marx believed that laws of human behavior or laws of society are specific to stage of development of society and are closely associated with mode of production or tools and techniques of production and ownership of tools and techniques of production. To Karl Marx, who think that a modern society is a capitalist society, religion is the dependent variable which needs to be explained in terms of class relations. And when he says that religion is the opium of the working class, it means that religion is used by the powerful class, the class which owns the means of production, to legitimize their class position or to confuse the workers. Let the workers think that if they are poor, if they are exploited, and if they suffer from various kinds of problems, it is because of their fate or their deeds in the previous births, and not develop the revolutionary consciousness to analyze the real causes of their poverty or exploitation or ill health. This is one view, and religion is the dependent variable, which also means that tomorrow in socialist society or in communist society, if it ever emerges and society becomes classless once again, religion may not exist. Now, according to another view, Max Weber, religion is actually the independent variable that explains emergence of something else, and that something else is the emergence of capitalism. Max Weber said that unlike in the Hindu countries or the Muslim countries or Christian countries where influence of Catholic Christianity was rampant, capitalism, as we understand by capitalist institutions, capitalism could not have developed. It does not mean that people, Hindus or Muslims or Catholic Christians, they were not acquisitive in nature, but there was a difference between them and those influenced by Protestant ethics in certain countries of Western Europe. And the difference was that these people did not use what they earned from their enterprises for comforts or for saving or for security or for status or prestige, but whatever they earned from their enterprise, they further invested this in the enterprise itself, and they lived simple life. By living simple life and spending the earnings back in the enterprise leads to emergence of capitalism in Western Europe. Here you see that religion is the cause. So, at some point of time, some philosopher, his name was Calvin, who gave a new turn to Christianity and propounded the philosophy of a new philosophy of Protestantism, also called Puritanism, the theory of predestination, which created anxiety in people's mind to know whether they are elect or not, whether after their death they will go to hell or heaven. So, this reinvesting in enterprise and not using the profits for their own gains or for their own comforts, this produce capitalist society or industrialization, in simple language industrialization, or this produce economic development first in the countries of Northwest Europe. And another issue which sociology tackles with regard to religion is whether we are secularizing. Now, it has been found that in the Western countries with urbanization, economic development, industrialization, education, democracy, there is a fall in religiosity. But in our country, secularization is defined in a different way, because we are a plural society, and for thousands of years all religions have been juxtaposed in our country. So, we define secularization as a process in which a state maintains equal distance from all the religions, but does not become irreligious state. So, but this kind of definition or this approach of a state obviously is going to raise new issues, new social problems and religious issues, other issues, but this is what it is. So, sociologists of religion will also study this process of secular tensions in the process of secularization in a plural country like India. Thank you.
Many a times we all think, who am I? Why am I doing whatever I am doing? Why do I feel attracted towards others? Why do I feel very aggressive in certain instances? Why certain people or certain type of acts, they repel me? Why is it that I always search for certain things which look very, very ambiguous? These are the things, these are the questions that all of us experience, all human beings. And you would realize that many a times certain domains of knowledge, especially within social sciences and all sciences at large, when you look at it from a philosophical point of view, they would try to give you the answers to these questions. Now, one of the branches of understanding which helps you understand things much better, which also helps you understand not only what is visibly present before you, what is glaringly apparent to you, rather which also tells you what is not visible at all, what goes within. Okay. And this is the subject knowledge, what is called as psychology. It is not only that it helps you understand the manifested behavior, the overt behavior, how you talk, how you speak, how you say it, how you interact, how you respond, not only that, but also what goes within, what makes you do this, what makes you think this way, what makes you act that way. Why is it that certain things you appreciate, certain things you feel attracted towards, and why is it that many a times in certain type of situations you feel you should completely go out of it, you should not get anyway involved into it, the repulsion. Why is it that certain acts, although you do not appreciate, still you get involved into it? Then you reinterpret your own behavior and you start giving birth to certain type of experiences, shame, guilt, pleasure, appreciation. You see world in a particular way, you analyze it in a particular way, you derive emotion out of it, feeling out of it, and the mix of what you perceived along with what you experience, it makes you act in a particular way, respond in a particular way. Your response is received by somebody else, and then the other person also responds in that situation. Now, there are situations where several people interact simultaneously. The situation remains constant and different people interact at the same time. You realize that your identity gets lost. You are not an individual. You act what is called as group behavior. You realize that you do not have an explanation for either favoring somebody or completely being unfavorable to the other person. You later on realize that it was a favorable or an unfavorable attitude towards that individual. You realize that you repeat certain form of behavior. Why? You do not know. People tell you that such type of repetitions are not normal. Human beings largely do not do that. And then you realize that okay, this is a particular pattern of a behavior for which I require the help of a specialist. The specialist tells me that this pattern of behavior is given a particular taxonomy, a particular nomenclature, which is either some aberration in the normal behavior, it is a neurotic form of a behavior, psychotic form of a behavior, it could be a psychosomatic response. And psychology, it covers all of this. So, if you want to understand yourself, if you want to understand others, this is the subject which helps you achieve that target. It is behavioral sciences that makes you understand human beings, human responses, human existence in complete totality.